Hi, welcome back to our class. Today we are going to discuss about the displacement reactions. See, displacement reactions, it is one of the types of chemical reactions. What is displacement reaction? In a chemical reaction, if one element displaces another element, then that type of reactions are known as the displacement reactions. See, how we'll represent this displacement reactions? That is AB plus C giving rise to CB plus A. See, in this AB and the C, these are the reactants. This C element, it is displacing A. Means what? Here C is more reactive than A. So it is forming the products CB plus A. But if you take CB plus A, CB and A as the reactants, it will not form any products, means no reaction. Here why? Because A is less reactive than C. Okay. See, it is fine. But how do we know that which element is more reactive and which element is less reactive? For that, the orderly arrangement of elements had done. That arrangement of elements according to their reactivities is known as the metal reactivity series. In this, only specially the metals are arranged in their order of reactivity. So with this order, what we will get the information? That is the relative reactivity of the elements we will get. Okay, now we will see what is that order. So now let us know about the metal reactivity series. This is the arrangement of metals according to their reactivity. In this series, the more reactive metals are kept at top, and from top to bottom, the reactivity is going to be decreased. Means the topmost element is the more reactive and the bottom element is the least reactive. Now let us see the sequence of the metals. See, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver, argentinum, hydrogen, argentinum, rm, that is gold, platinum. This is the arrangement. In this, the reactivity decreases down the series. See here, potassium is more reactive than sodium. Sodium is more reactive than calcium. Calcium is more reactive than magnesium. Magnesium is more reactive than aluminum, and so on. Now, one example, that is, if you take copper sulphate and if you take iron, this reaction you have learnt in class 7th science. See, this iron displaces copper. Iron displaces the copper and copper is going out. So it is forming iron sulphate plus copper. This copper sulphate will be in which color? In blue color. And iron sulphate will be in green color. So we will get the green colored solution. And here copper is deposited. Okay. But if you take iron sulphate and copper, we will not see any reaction. Means here, what is the thing? That is, iron is more reactive than copper. Is it true or not according to our metal reactivity series? Let us check now. See, where is the iron? Here. Where is the copper? Here. Iron is on the copper. Iron is at top than the copper. So, iron is more reactive than the copper. That is the reason iron is displacing the copper. But copper cannot displace iron. That is the reason if we take iron sulphate plus copper, reaction will not be there. Now, one more example from this series only. That is, if we take copper sulphate and zinc, it will form zinc sulphate and copper is deposited. Copper is separated. But if we take zinc sulphate plus copper, we will not see any reaction. That is no reaction. Why, children? Again for the same reason. That is, where is the zinc and where is the copper, you see? See, here is the zinc. And where is the copper? Here. Copper is down to the zinc. Means zinc is more reactive than the copper. That is the reason zinc is displacing the copper. But copper cannot displace the zinc. Okay. Now, let us see. Halogens are also orderly arranged like this according to their reactivity. So now let us see about that series that is known as the halogen reactivity series. Halogen reactivity series. This is the orderly arrangement of halogens according to their reactivity. That is fluorine, chlorine, bromine, iodine. These are known as the halogens. In these, fluorine is more reactive and iodine is the least reactive. And from fluorine to iodine, from top to bottom, the reactivity decreases. How do we represent these reactions? That is, if this is a just representation, AX plus B giving rise to AB plus X. Means what here? Both B and X, these two are the halogens only. But here B is the more reactive halogen than the X. That is the reason this B is displacing X. That is the reason AB is formed and X is released out. Okay. For example, if you take sodium bromide, NaBr is known as a sodium bromide. If it is reacting with chlorine, as chlorine is more reactive than bromine, this chlorine is displacing bromine. That is the reason sodium chloride is formed and bromine is released out. But if you take sodium chloride plus bromine, what do we observe? Nothing. There is no reaction. Why? Why? Because it's reactive than the chlorine. Okay. This is the halogen reactivity series.